All right, I think we're going to go ahead and get started. Um, Thanks everyone for joining us on the webinar today. My name is Justin Chittick. I'm with the Aidex Corporation. And I'll just give a quick introduction to Aidex in case you're not familiar with us. We're based out of Rossville, Indiana, and we're a company that provides technical training solutions for STEM and CTE programs. We've been in business well over 30 years, and we cover a 6-state region, including Indiana, Illinois, Missouri, Kansas, Iowa, and Nebraska. The purpose of the webinar today is to introduce LJ Creates Auto Lab program that includes cloud-based curriculum, virtual simulations, and hands-on trainers that make up a complete automotive program aligned to the ASE skills path, excuse me. Aidex is a local representative for LJ in Indiana, Illinois, Missouri, and Kansas. Before we get started, if you have any questions during the presentation, feel free to use your chat box at the bottom of your screen. You can type your question in and we'll answer all those questions at the end of the presentation. So with that, I'd like to introduce Mark Weiss, who is the VP of Sales for LJ Create.
Thank you, Chad. Thank you, Justin. Sorry. Good morning, everybody. Thank you for attending. And we'll kick it off with basically just giving you a quick introduction into who we are as a company. So I am with LJ Create. We are an international based STEM resource provider. Been in business since 1979. Our North American headquarters is in Orlando, Florida. Sunny Florida. We have over 100 employees in product development and client services, and we have representatives working across the continents. And as Justin mentioned, Aidex is our contracted distributor for our products in the states that he mentioned. Our objectives have been to engage all learners in hands-on STEM and to equip the STEM workforce and help bridge the widening skills gap, to pioneer new techniques and innovation. So we've been doing this for quite some time, and we've always tried to move with the technology and create what we call blended learning for these types of career type of programs or skill development programs. What we do is we develop digital learning content for STEM education and career training. And for the purpose of this meeting today, we're going to discuss specifically our automotive materials, but we do have curriculum for other subject areas as well. We design and manufacture hardware for development of the career skills, and offer a complete blended learning course via our cloud-based LMS, which is our learning management system. And we also provide consultancy, professional development, and technical support for educators. We work with K-12 education, technical colleges and universities, education districts and ministries across the world, and commercial and private training and military training colleges across the globe. The Autolab program itself is designed to provide a student learning journey through the ASE skills path. Normally, I would have said in the years going by, it would have been the NATEV skills path. As we know, NATEV, AYS, and AES all merged together to form the ASE Foundation. So we'll now address it as the ASE skills path. To develop automotive repair knowledge and skills, introduce a range of high-tech skill areas, and to be able to run flawlessly in the classroom, and to support whole class instruction, and to integrate math, science, and English language arts lessons across the technical subject area. We incorporated 2,300 lessons of our Autolab into our Working with STEM library, which now provides over 6,000 hours of instruction in occupational skill development math, science, and English language arts skills, which now does make AutoLab the most comprehensive curriculum developed for a specific set of occupational standards and academic support. In most of the academics, math, science, English language arts, you'll see when we look at the content, is to support the technical subject area that the students are working through. We are a complete system of hardware and digital content that is easy to integrate into any existing programs, and this is going to be a key focus of what we're going to talk about. One of the things that we did at the company years ago was make our program as flexible as possible to fit into any scenario or any set of circumstances that you may have within a program. Whether you want a complete system, whether you want to use just the curriculum component, or whether you want to use just some automotive trainers, if you would, to basically focus on areas of specific needs. Our trainers will come with a subset of our curriculum, so it's not just a piece of equipment left for the teacher to have to figure out how to use and when to use. And we'll get into more details on that as we move through. There are 3 levels of program certification, as we're all aware of. So there are programs that are certified in MLR, Maintenance Light Repair, AST, Automotive Service Technician, and MAST, which is the Master Automotive Service Technician. Each level requires completion of the 8 learning areas of the technical areas and additional related academic and workplace skills. So what we've done is we've aligned our curriculum to the 3 certification areas and then provide the appropriate curriculum to address all 8 of those areas. So for each technical area, a number of tasks have to be completed, and we provide a lesson or a series of lessons automatically aligned to every task, leading to the formal assessment task of over 450. So as you can see from the screen here, if I was a program doing AST, I'm still going to have to teach all 8 areas. And within 8 areas, if we were looking at engine repair to start with, you can see that we provide a series of lessons starting with a pre-test, a couple of lessons related to a specific task, then there'll be a different task, another task, and then finally a post-test, which is how we can show competency gained. Task, we provide a lesson or a sequence of lessons and a formal assessment. Each sequence starts with a knowledge lesson, which is in the form of a theory-based presentation, and an assessment and feedback path to ensure every student is on track. This is followed by a number of skill development lessons that we will use either on trainers, demonstration rigs, and eventually even in the workshop. So what we're showing here in this chart is basically we have a task that is related to engine repair. We have 2 lessons covering that specific task. The lesson is broken down into a theory presentation, which will give the students short, sharp bits of information that will enable them to now physically apply them in an investigation. In our investigations, these require no hardware. The investigation will use virtual labs, simulators, interactive animations. They may be parts identification, research activities, charting, writing activities, leading to a knowledge assessment, which is a test to the student on their theory related to the theory presentation and the investigation. If the students do not pass or they need more help, they can always go back into the theory and redo the investigation again. If the students do pass the test, they then move on to the next section, which is a practical activity that is going to make use of a trainer, a section rig, or a workshop task related to the theory component. Following that, we will give the students an assessment on that practical hands-on assessment, and that then leads the students into the next lesson in a series of lessons. We also will provide within the program all the materials required that teachers must have, and that includes the assessor ASC instructor tracker reports, so that the completion of every task can be tracked and dated for each of your students. So within the program, you'll see that we provide all of the NATEP or ASE checklists, as well as we provide all the performance assessment sheets for every task that's required to be done within any one of the 3 certification areas. Our lessons are built around a large collection of interactive digital content. And as I said, we'll start with presentations, which are full functional presentations with animations, video clips, questions, voiceover, investigations, as I mentioned, which will be in a variety of different modalities, student assessments, and then we also provide some virtual simulations. And this is all tied around our learning management system, which does all the tracking and grading for you. And that LMS is broken down into 3 components, which we should speak about, which are 1, a series of courses that are aligned to specific standards and or certifications. The second component is a series of libraries, which think of them as being books on a shelf that are based on a topical area or a subject with the learning material for that specific subject in there. And then the third component is an editing facility where teachers can go in and use out of our courses or our libraries and create your own courses, your own sequence of how you want to deliver the materials to the students. So it is a full comprehensive learning management system that can make use of reporting facilities, tracking of your students. And it's really important when you're doing online learning to be able to have live data to see who's been logged on, what they've worked on, things like that. Our knowledge lessons, we use a number of different on-screen active learning. We have a series of powerful software simulations. Here on the screen, you'll see just a couple of them. We have some simulators for OBD2 diagnostics, where you can put faults into the vehicle on screen, and students will have to go in and use their diagnostic tools and the Mitchell on demand and figure out what's going on with the car and fix the problem. We do the same thing for CAN bus lighting, hybrid and vehicle technologies, electronics, hybrid exhaust system explorers. So we have a lot of interactive pieces that go along with our materials. We also make available a number of hands-on lessons, and we provide a range of hardware trainers designed to simplify the ASE preparation process. So we can provide a series of cutaway and demonstration type units. We have some units that some programs don't have the facility that are big enough to address certain tasks. So ASE allows you to use certain trainers for certain hands-on applications, such as the braking rig or steering and suspension rig. We also have panel trainers that simulate certain activities that might not be appropriate for a classroom activity or a workshop activity because of the liabilities that they may cause, such as hybrid electric, where you're working on high voltages, where we can do it using our simulator in a safe and clean environment. And then we have our autotronics, which are our small electrical trainers, which we make use of in a number of different ways. And I'm going to focus on this in a few moments, because I think it's important that we realize that electrical is probably the hardest thing for people to teach, because it's very hard for students to visualize current flow, resistance, without having some means of actually having students apply it. It makes it very difficult. But in a lot of cases, in order to do that, you have to buy very expensive equipment. We put together a series of these smaller footprint trainers to make them affordable, but also so that you can have classroom sets to actually teach the harder subject matter within the curriculum. So with that, let's take a look at our Autotronic training equipment. And since the late 1990s, all vehicles have used serial bus technology. And it's now required to control all aspects of the vehicle, whether it's your auxiliary system in the car, your windows, your seats, your power mirrors, even in your ignition system and your charging system, as well as your lighting system. Everything is now networked through a series of CAN bus systems to control what's going on in the systems. Our CAN bus troubleshooting trainers are not required to teach CAN. They're essential for teaching all post-2000 Autotronic systems. Without having something like this, it's very difficult to get students prepared to be able to do diagnostics on CAN bus systems. We also have created a basic electrical circuit trainer utilizing 15 years of experience to solve the most difficult auto training problem that most instructors say they have, and that's to teach auto electronics to students. Nice thing about this particular trainer, it's in a smaller footprint. We do have programs at post-secondary as well as secondary that have transitioned now to more online learning because of the COVID-19 and not knowing what's going to happen further. Because they have class sets of these and they're in a very smaller footprint, there are some schools that are being able to loan these out to students and still be able to actively engage the students in hands-on activities from home to cover their electrical training. The 700-10 trainer is our basic trainer. And basically, you'll see here it's broken down and we have a protective cover which folds back to provide an angled support for the unit. You have a power on-off switch to isolate the board from the power supply. We have a patching area where students will use carrier-mounted components, shorting links and connecting leads to build and test the circuits. Your battery connector connection, which is a 12-volt supply and a ground for powering the circuits on the patching area. And a integrated fuse, a resettable 630 milliamp thermal fuse for protection of the complete system so that if students do short something out, this fuse will pop and simply let the system cool down for a couple of seconds and then just press the fuse and your system is back up and running without any damage to the actual components on the board. We provide 6 switches for student experimentation. They include push button, on, off, and changeover types. There are 3 lamps, 12-volt lamps. And we have integrated into the curriculum a series of practical activities that the students will do with this, including a whole series of activities covering basic electrical concepts and troubleshooting on a very easy to use piece of equipment. We then also make available a CAN lighting board system, similar in size to the basic one. And this system is also broken down the same way where you have your CAN bus system for turn signal, park lights, license plate, low beams, high beams, fog lights, stop lights, rear fog lights, backup lights, and your light switches. And then the other components, your high beam, your turn signal switch, your hazard warning switches, all your switches in your vehicles that you can make use of. And basically then we broke down the different CAN sections that you can actually take full measurements at to see what's going on and see how it's communicating between the ECU and the different systems. One of the things that I want to point out right off the bat is we make use of these jumpers and pins as a way to show a comparison to the way it would be on the vehicle. So in the vehicle, you're going to have your connectors, your harnesses, and your connectors. And when they're in the closed position, we'll replicate that on our boards as having the jumper connected to the pins. When you're disconnecting the connectors in the vehicle, to do it on our boards, you basically remove the jumper, and that's the same as doing that. And then the students will be taking their voltage readings from these pins, just like they would from the connectors themselves. On the side of each of these boards, there's an area for you to be able to select and insert faults, so you can actually do fault diagnostics with these trainers. There's a digital display to show each of the faults for the instructor so that you know what fault you're putting in. There's a USB port so that you can upgrade the lighting board. If there's any firmware updates, you can automatically download them. And then a DC power socket connector for the 12-volt power supply. And basically, that's just showing the lighting board. We also have a CAN auxiliary board similar to the lighting. This one is going to address your power windows, your power mirrors, your door locks, and your seat controls. And it's going to work the same way. And then we also have one for engine control, starting and charging systems, which will also work exactly the same way as the other units. And then some of the system panel trainers that we provide, and this is just a quick look at stuff. We have engine management trainers, we have hybrid and electric vehicle trainers, ABS, and there's a number of other simulated trainers. These are tabletop panel trainers. They're slightly larger than the smaller electronic trainers. But the reason that these are good to have to make use are, these are designed to be used specifically on areas that are possibly difficult for you to show students all the different components in a live vehicle. So for instance, ABS, this is a great trainer because although you may have vehicles in a live situation where either you're going to have to go out and fault or cut wires to make something happen, the students may not get a chance to see everything that they may be able to see on our trainers, because on the trainer, they get to see all the different sensors, how they work. You can put faults into the sensors. They have diagnostic tools to test the electrical side as well as the mechanical side. So these trainers are set up to be able to enable you to show the students more, not less. Same thing with the hybrid and electric. Here we not only show the mechanical side, but in a very safe, clean environment, we can have students explore and troubleshoot the high side of a hybrid and electric vehicle, which you can't do in your classroom. Basically, what we do here on the high side is we have, it's hard to make out here, but around the high side electrical, there's a orange ring. And where the students make pinpoint connections, they'll be getting a regular reading of, say, 12 volts or 12. And then underneath the pin, there'll be a multiplier, say 10. So they'll multiply that 12 by 10 to get 120 volts at a certain component, which would be the proper reading for a voltage on, let's say, a series parallel. So this trainer actually is a series parallel vehicle, will react to a fault the same way it would if the car actually came into your shop. We also provide component rigs for things like fuel injection, air conditioning, electrical and charging. We also provide a series of engines with CAN bus, without CAN bus, but all the engines are also integrated with fault insertion so that you can use them as a application trainer. After teaching engine performance, you can go out into the shop and very quickly, without having to destroy a vehicle, put faults into the engines and have the students take their measurements and try to analyze what's wrong with the vehicle. And we also have a series of medium and heavy duty demonstrator trainers as well. Same thing, we have full functioning 4 6-cylinder diesel engines with fault insertions, cutaways, axles, tractor trailer air brake trainers. There's a whole series of trainers. We also have 2 panel trainers for medium and heavy duty covering electrical and engine performance. With that being said, let's take a look now at what the materials actually look like from a content point of view. So I'm going to log into my learning management system here and just give you a quick overview of how the curriculum is laid out and how you might use it within your program. I'm logged in as an admin on my site. So I'm going to come in here and I'm going to take a look at, let's do MLR. Let's go to the 2017 standards. And let's take a look at, since we were talking about electric before, let's use electric. So let's go to electric general. And this is a full course covering electrical. And on the screen, you're going to see the screen is split into 2 components for the teacher. On the right-hand side, here are all your standards that are integrated and aligned from NATEP, and these are based on the 2017 standards. This is really great to have because if I take a look here on this side, I see electrical fundamentals. If I click on electrical fundamentals, which is the topic, you'll see that it filtered out for me. These are the ASE standards that we're going to address underneath electrical fundamentals for MLR. I can also click on the individual objectives and it'll filter out the learning units for me to show me the exact learning units of where we're going to cover each and every single one of those topics. So we have invested a lot of time in integrating the standards for you so that when you're teaching a specific topical area, let's say simple circuits, students will be able to click on simple circuits and filter out and show them what objective that they're actually addressing by going through this lesson. So that's an important feature that's built in. We also provide a series of supporting work to support topical areas. So for instance, in electrical, we have supporting lessons for electrical measurement, which students could use if they don't remember how to use the test equipment. They have full functioning lessons for that. We have lessons on electrical safety and accident prevention to help them if they need. And then we get into things like mechanical measurements for them. So if they don't know how to do calculations for specific areas, machine and instrument engineering, maintenance and repair, then we get into the academics of the science, the engineering mathematics, and the English and reading and language skills. So these supporting lessons are going to be built in and students can address them from within the actual lesson that they're going to be in. And I'll show you how that works in a second. The third component here, because we're on the teacher side, are the teacher resources. And again, we provide a complete breakdown of equipment that is aligned to the NATEP tasks. So if you wanted to look at equipment that you may be interested in to address specific tasks, we have it all broken out by the 3 areas under the topical area. And based off of the task number, we can show you what piece of equipment we have that you could use to address a specific task. So that's available under the teacher resource. And then again, we provide all of the checklists for all of the areas. So for instance, electrical electronics, you can have this printed out for all of your students. And this is basically your NATEP checklist showing the code, what the NATEP task is, what the priority is, and then what the hands-on lesson is. If it was a hands-on lesson, was it there a practice hands-on lesson, and then where the assessor marking sheet would be. And then basically you can keep track of your students' progress through any one of the learning units as they work through a subject area. And we provide that for all 8 areas, and we provide that based on whether you're doing MLR, AST, or MAST. So within the teacher resources, there's a lot of materials here to help you better help your students. Now, on this side, this is where the content side is. And as I said earlier, we start everything with a pretest. The pretest is going to be a test of about 50 questions to just basically test students' knowledge prior to going through the content. Because when we finish the course, at the very end, we're going to give them a post-test. So their post-test will basically show you competency gain that they gained after going through the entire series or the entire course. The course itself is broken down by topical areas. So we start with electrical fundamentals, and there's a series of lessons, electrical components in operation, electrical supply, so on and so forth. Within each topical area, there's going to be a series of lessons. So we start here with simple circuits, and you'll see there are 3 different icons under simple circuits. And that's because, as I said earlier, we broke the content down in more short, sharp, digestible things for the students to do. So we start with a theory presentation, which can be delivered by the teacher or by the students on their own. Because I'm on the teacher side, we give you, the teacher, the ability to download all of the presentations in PDF if you need to hand them out. We also give you the ability to download them as presentations if you want to keep them. On the student side, they have access to switch on audio. So if they need screens read back, they can click on this button here, and that will then read screens back to them. And then basically it's a series of 20 slides that's going to give just short, sharp bits of information, a graphic, an animation, a video, something related to what they're just learning, because we want to make it digestible, but we want to make it just quick, short, sharp bits of information. So we're not making them do a lot of reading. And then there might be, after a series of screens, a set of questions that might pop up. Now, the questions here are not being assessed. This is used if the teacher was delivering in the classroom as a break point to see whether the students understood what he just taught, or do I need to go back before I continue forward. So basically, that's how the presentations will work. And again, some of these will be a little bit more dynamic than this particular one is a very basic one. And you just work through the presentation until you get to the last slide, which is basically going to be a summary identifying to the students what they should have learned. So a simple circuit is produced when a lamp is connected to a battery using wires, and a digital multimeter can be used to measure DC voltage. Again, very basic, but it's, again, the very beginning of what we're going to do. Once you come back out, excuse me, when the student has done something, it'll turn green. That allows you to see that the student has done it. Now the next phase is to click on the magnifying glass, which is the investigation. And in this particular case, the investigation also is voiceover, so it can have the screens read back. It could be printed out and handed to the students. And in this particular investigation, it's going to make use of one of our simulators. In this particular simulator, it's a sophisticated simulator. And although 95% of all of our material has been converted to HTML5, there are a few simulators that just can't be converted. These will require to be to utilize Flash. If you're using a PC, but you're not allowed to use Flash within your school or on the school computers, we give you the ability to download the actual files to the local computer. And while the students are online doing their curriculum, they'll be able to launch the application direct from their machines, so they can still make use of the simulators without having to have actually flash enabled within their browser. In this particular one, we're just going to click on the virtual simulator. And just to give you an idea of how it works, it's quite simple. I'm going to take a 12-volt battery. I'm going to come in here. I'm going to take a lamp, and I'm going to make sure I take a 12-volt lamp. Although if your students wanted to take the 6-volt lamp out, they could. It will blow up. But unlike being in your classroom, you don't have to go replace equipment because this is virtual, so we just return it to here and bring it back out, and you have a new bulb. So here I just connected a quick little circuit. One of the things that I like to show teachers here, it's very important. Remember what I said earlier, it's hard for students to visual electrical flow and things like that. What's even more important is we need to start teaching the students how to go from a graphical interface to what that looks like in a schematic. So when they're building and constructing their circuits, they can quickly change it from a graphical to a schematic, so I can see what a battery is going to look like in a schematic, and what does a 12-volt bulb look like in a schematic. And then I can switch back and forth. In order to operate it, I'm just going to click on it. The bulb will light up, of course, and now I can take out my multimeter and I can go take a measurement, and lo and behold, I have a 12-volt reading. So it's pretty simple to use. One of the things you'll notice is in the curriculum itself, we do not show the students how to use it. We tell the students what we want them to do, but we don't show them how to actually do it. And the reason for that is what we're doing is we want to make the students be able to use their other skills, which they're lacking, and that is problem solving and being able to do research. So within the simulators themselves, we built in help facilities for them so that if they can't figure out how to use it, all they have to do is come here. How do I add a component? It's ensure the construct mode is selected, select the category from the drop-down menu, and drag the component. So very quickly, students can come in here and learn how to use the simulators on their own very quickly without really doing much. And again, these simulators, the other things you can do on the simulators is we can show electron flow, we can show conventional current flow. So there's a lot of things you can do within the simulator that are very helpful when you're teaching these type of electrical courses. And basically, because I'm on the teacher side, just so you know, we basically give you the teacher guide built in so you know what the expected results are for the assessments and or the investigations. Now on the student side, when they're in a topical area, you'll notice this button up here that says support material. If there is any support material that supports the specific learning unit that they're working on, they can click this button and come to support work, and this will show them the supporting work that is here to support them. So since we're asking the students to do circuit and take voltage readings, if they don't remember how to use a multimeter, here's a lesson on measuring voltage. So I can click on the icon here, and this will bring up a tutorial presentation on measuring voltage so that they can now go back through it and refresh themselves on how to use a multimeter. And all they do is click back to course and they're back into it again. And then here's a series of science lessons built around series circuits, parallel circuits, but it's going to look at it from a science perspective rather than a technical perspective. So if there was math, there would be math in there. So we make available the supporting materials for everybody. Once you finish the investigation, now come back out, it turned green. Now it's time to take the assessment. Click on the assessment. The assessment for this learning unit I've already done. And basically it's just a short 6 questions. And basically the questions could be true, false, yes, no. Technician A says this, technician B says this. Put in the voltage readings, do calculations, things like that. And it's just 6 questions, but it's basically testing them on the theory component and the investigation. Once the students hit submit, click short report, they're given a score. They can print it out and keep it. We'll show them what they got right and what they got wrong. If you're worried about students sharing that information, in your class settings, you can have that turned off so it doesn't show them what they got right and what they got wrong. It'll just give them a score. You got 1 out of 6, and then you can go back in, unlock it, and let the students take it again if you wish to do that. Return to course, and now you'll see under that there's a series of battery and lamp circuits, and that has a hands, and that says next to it, make use of one of those boards. This is a hands-on activity that's going to make use of one of the boards that I just showed you earlier. And in this case, the students would click on that. Basically, it's going to give them lab work, telling them to go get their 700-10 electric board and their patching kit, and they're going to have to go and build circuits and start doing circuit testing and filling in their voltage readings here in a hands-on activity. And as you see, there's a series of different activities using that piece of equipment. Once they finish that, they then come back in, and now we're going to do an assessment on the practical activity. So we not only are testing the students on the theory and the investigation, but if you have the equipment, and if you don't have our equipment, you might have another piece of equipment that is similar that you may be able to still use this hands-on activity in your program. If you don't have the hands-on activity, you would skip the hands-on activities and just go to the next group of lessons. But within the hands-on activities, you'll notice we do list next to it whether it's, what piece of equipment it is. And you will see that there'll be a series also of ones that say workshop. If it says workshop, this is a task that we're asking the students to go out in the shop and perform a task on a live vehicle. In this particular case, it's to fix wiring in a vehicle. And basically, we'll give the students the task, we'll give them a job sheet, we'll tell them what we want them to do, and then basically they have to go out and perform the task out in your shop. So that's integrated right in as well. And then the students will then move on to the next series and so forth. And that's how it basically works all the way through. And again, now I'm going to show you, that's a course. And of course, we have a course in MLR for all 8 areas. But you'll also have access to what we call libraries. So if I go and click Library 3, and maybe I just wanted to, I don't want to use a course, maybe I just want to create my own course, or I want to just teach a specific section, let's say braking, for instance. I can come in here and click on braking, and here is a course on just braking topical areas that somebody made, which is interesting because they took, it looks like engine, it is engine repair. So somebody took our engine repair and made their own course. So, but you'll see that in the libraries, it's just the topical areas, and then it's the individual learning units, but there's no integration to any of the support work or any of the standards. But it is there for you to use, and you have access to any one of the library items for automotive to be able to use. If I wanted to teach just braking, or I wanted to see what's in the braking system, these are copies. So let me get out of the copies and just go to a full library. Sorry about that. Copies mean that somebody took them and edited them. So if I come down here and say brake systems, here's the brake system book, if you would, starting with brake system fundamentals, hydraulic controls, warning systems, anti-lock braking systems. And again, it's the same thing. We have the curriculum and then the hands-on activities. Okay. So basically, that's the way the curriculum works. You get a license for unlimited users when you purchase the site. And then we provide all of the training for you that enables you to make use of the materials. We can put this together as a complete auto lab, where basically we can build a facility where there's a lab, interactive instructor presentation area, skill practice trainer rigs, and then of course where the job sheets can be used. Or as I mentioned earlier, it could be broken down by just using the curriculum or just a piece of equipment that's specific, because a lot of our equipment does come with a subset of the physical curriculum or the practical activities for that particular trainer. And with that, I'm going to turn it back over to Justin, because that's all I have, to see if there are any questions. And Justin, if you want to open it back up for questions, I'd be more than happy to address them now.
Yeah, thanks, Mark. Doesn't look like we have any questions in the chat box, but I'd like to open it up. If any of the attendees have any specific questions for us, you can unmute yourself and go ahead and ask your question. All right. All right. Well, in closing, I wanted to mention that we also have a sister company, Buckeye Educational Systems, in case any of the folks in Ohio, Michigan, or Kentucky hear the webinar. Just want to introduce them. They are the local rep for LJ Create in those 3 states. Chad Wilford would be the contact for Ohio. And then Ohio and Kentucky, and John Horowitz is the Michigan rep. So there is the contact information for Buckeye. Yeah, I'd also like to mention if anyone would like a follow-up webinar to go over your program specific needs and how we can potentially help you with your program specifically, we'd be happy to set that up with you. Also, if you'd like a login for the LMS, we'd be happy to create a login for you and send that over so you can go through the curriculum in detail. So I think that's it. I really appreciate everyone being here today. Again, feel free to reach out to us with any questions, and if there's anything we can do for you in the future. All right. Appreciate it. Everyone have a safe and fun Memorial Day weekend. Thanks again.
Thank you.